This video is for the basketball players who are missing pre-cal trig on Friday, January 11th. And the rest of the class would like to say hello.
Hey!
Okay. All right. Now, we are in your notes where we left off. Area of oblique triangles. Did we do anything on that page?
Nope.
Nothing. Okay. Now, an oblique triangle just means it's not a right triangle. That's all. When you were in geometry and even in later elementary, you learned how to find the area of a triangle. And you learned a formula. Area equals 1/2 times base times height. Now, you know that the height of your triangle has to be from one of the vertices to the opposite side perpendicular. What if you are not given H? You will not be given H. So the issue is you got to go find it. So that's what we're going to talk about for a little bit. This is not, no, stop it. Okay, it is not, the word apothegm does not come up unless you just choose for it to come up. Now, what we want to do is rewrite this formula in terms of trig ratios. This is super easy. Suppose we know that the length of B is 9, so put those in there, not in yellow. The length of A is 17, and the measure of angle C is 67 degrees. Now, I want you to look, come on, I want you to look at this triangle. Now, that's a right triangle. Because it's a right triangle, I can use a trig ratio, and I can calculate the height. Now, from that right triangle, I know this angle, I know this side, and I want to know this side. For this angle of 67 degrees, what is side H called? Opposite. What is side B called? Hypotenuse. What trig function relates opposite and hypotenuse? Sine. Sine. Yep, it's all right. So, we're going to use sine, okay? Use a trig ratio to find that variable. Okay, so we're going to use sine of C, which is 67 degrees, equals H over what? Over 9. How do we solve that equation for H? So we get H equals 9 times the sine of 67 degrees. Now we know what the height is. Use your calculator, but please make sure you're, can't talk, make sure you're in degree mode. If you're in radian mode, you will be totally screwed up. Did you get about 8.28 something? Okay, 8.285. Now, store that. Just hit store. And let's just store it somewhere. And you can store it wherever you want, but I'm going to store it in A. Alpha, then A. You do store and then alpha A. Now let's go find the area. We know that the area is 1/2 times the base times the height. What is the base? 17 times the height, which we have stored, right? So do 1/2 times the base times the height. Yep. So the area is about 70.419. Now we would say square units, but we don't know what unit, so you don't have to put anything if you are not given a unit. Now you say, well, okay, that's all fine and good, but I want to just show you a little formula where you could just do it all in one shot and not have to, okay, I'm going to go calculate h and then I'm going to go find the area. What I want you to look at is the relationship between where these pieces are located. Now you're thinking, what's she talking about? Okay, that was 9. This was 67 degrees. I've got this side here, this angle, and this side here. That's right. Now, that angle C is called the included angle between sides A and B. Do you understand what included angle means? An included angle means if you have two sides that touch, it's the angle that those two sides make where they touch. So what this is, the formula is 1/2 of, multiply the two sides, times the sine of that included angle. Now, I'm going to write this up so you can understand it real well. Area equals, now we know it's 1/2 times base times height. In this particular case, what was the base? 17. What we knew was the 17 and the 9, right? Hang on just a second. It was 1/2 times A times B times the sine of what? Well, what angle was it? C. Area equals 1/2 AB sine C. We'll pick up there after lunch. So, right before lunch, we came up with this formula. Now, there are two other ways that you can write that formula based on the sides that you are given and the angle that you are given. So, let's go back up here. If you were given these two sides, what angle would you need to know? Because B is the included angle with sides A and C. You with me? So we would write the area formula as, and write this down here, okay? I just don't want to have to scroll back and forth. As 1/2 of A times C times the sine of angle B. Now, what pair of sides have we not used? Here I used A and C. Here I used A and B. I need to use B and C. So if I knew B and C, what angle is the included angle? A. So I could also write an area formula as area equals 1/2 of B times C times the sine of angle A. All you got to remember is it's two sides and their included angle. And you got to use sine, okay? All right, next page. Now, I believe we have this side of a page and one more side of a page. Is that correct? Okay. Now we're getting to the good stuff. Solving oblique triangles. Remember, solving a triangle means finding all the angles and all the sides that you don't know. But these are not going to be right triangles, so you cannot use your trig ratios. Now, well, this would not be given to you. This would not be in the picture. You would not be given that, okay? The reason it's here right now is we're going to have to use it to develop some formulas. Now let's look right here. Using angle C, find an expression for H in terms of B. Now what in the world does that mean? Find an expression for H. It means H equals. In terms of B means I want B to be one of the variables in my equation. So, using angle C, find an expression for H in terms of B. So here's what I need you to think. For this angle right here, what is this side called? And keep in mind, right, because see, this is a right triangle, isn't it? And I can use my trig ratios because this is a right triangle. So H is opposite, What's B? Isn't B the hypotenuse of that yellow triangle? What trig function or trig ratio uses opposite and hypotenuse? Sine. So the sine of angle C is what over what? Opposite over hypotenuse, H over B. How do you get the H by itself? So I want you to write it this way. B times sine of C. Write it that way. Now let's go to this question. Using angle B. All right. So I'm going to go to this right triangle. Again, because it's a right triangle, I can use my trig ratios. Using angle B, find an expression for H in terms of C. What do you mean same thing? You mean same trig ratio? You mean use sine again? Yeah. So the sine of angle B equals H over C, opposite over hypotenuse. So H equals, don't make a big C, Stennett, make a little c because that's a side. Okay, and then the angels start to sing, because if H is equal to this and H is equal to this, they're equal to each other. So right here, B sine C equals C sine B. I heard somebody say transitive. Oh my goodness. Wow. Okay. Now we're going to take that equation right there, and we're going to divide both sides by little b times little c. Now remember, I can divide both sides of an equation by the same thing, provided that thing is not 0. How do I know b times c is not 0? Because they are side lengths. Can I have a triangle if one of those side lengths is 0? So b times c cannot be 0. Now let's see what happens. Here the b's cancel. Here the c's cancel. So look what I'm left with. I'm left with the sine of angle C over side C equals the sine of angle B over side B. Ladies and gentlemen, welcome to the law of sines. Now, if you look at that, you might think, well, there's some stuff we didn't use. That's right. There's one more fraction that we could put in there. Sine of A over A. Now, I don't like writing it like this. I prefer to use alpha, beta, and gamma as my angle measures, because if I say sine A over A, how do you know which A is which? Okay. So if I say sine alpha over A, then I know alpha is the angle. So in this law of sines box, I'm going to write sine alpha over A equals sine beta over B equals sine gamma over C. This is super easy to work with. Now and then you will see this on the ACT. They will always give you the formula. Now at least you'll understand what in the world it's doing. And what we're going to do is we're going to use the law of sines to solve a right, or not a right triangle, to solve a triangle. In triangle ABC, the measure of angle B is 130 degrees, and then it gives you side C and side B. Solve the triangle, finding all the other missing measurements. Please, when you draw this triangle, please notice that you have an obtuse angle. Please do not draw a triangle like that and put 130 degrees right there, okay? at least draw an angle that's obtuse. So, there's my triangle. I'm going to call that alpha, I'm going to call that beta, I'm going to call that gamma, which means this side is A, this side is B, and this side is C. I am told that that's 130 degrees, that that's 11, and that that's 15. Now, I cannot use trig ratios because I don't have a right triangle. I can, however, use law of sines. Now, one of these three fractions right here, I have to use. What I'm going to use is two of them. What I'm going to do is have, maybe I have sine alpha over A equals sine beta over B. Maybe I have sine beta over B equals sine gamma over C. Or maybe I have sine alpha over A equals sine gamma over C. One of those in this case I have to use. Can you think about that for a few seconds and see which one of those you think you have to use? Why do I have to use sine beta over B? Because I know the angle and the side. I know both beta and B. They will give it to, yeah. So I'm going to use sine beta over B. Now here's the deal. There's one of those pairs, or one of those fractions I can't use right now because I don't know anything. I can't use sine alpha over A because I don't know either one. So I'm going to use sine gamma over C because I don't know gamma, but I do know C. So this is the, that's a proportion, isn't it? Two fractions set equal to each other. That's what I'm going to use. Now let's fill it in. Beta is 130 degrees, so this thing is sine of 130 degrees divided by B, which is 15, equals the sine of gamma, I don't know gamma, over C, which is 11. Cross multiply. Law of sines is super easy to use. Cross multiply gives me 11 sine 130, and put the degree measure when you're dealing with degrees, equals 15 sine gamma. How do I get this sine gamma by itself? There you go. So I'm going to have sine gamma equals 11 sine of 130 degrees divided by 15. That's the exact answer for the sine of gamma. How do I find gamma? There you go. Taryn said sine inverse. So we're going to do the sine. Don't start this. Don't. Mercy. All right, here we go. We'll see what happens. We're going to do the sine inverse of both sides. So we'll get gamma equals. Now we'll have to do an approximate, won't we? Run that on your calculator. 34.178 degrees. Now I want you to store that because this is angle gamma, which really represents C. Let's store that in C. And I would suggest that you write that down to remind yourself where you put it. Did you all get this for your angle gamma?
Yes.
Okay. Now let's go back and see what we've got. Now we know gamma. I don't know. I don't know. I don't know. Now we know angle beta. Jeez Louise, quit. I don't know what's going on. You can do 180 minus 130 minus C and that will give you your alpha, correct? I know this angle and I know this angle. And remember, the sum of the three angles of a triangle have to be 180. Dadgummit. Wait, it went back to the beginning. So 180 minus 130 minus that angle, oh, snap. 15.822 degrees, yep. So we've got alpha is approximately 15.822 degrees. And remember, you're circling those or boxing them in so we can find them. What's the one piece we're still missing? The side. We need side A. Now listen, I forgot to tell you, let's store that. I'd store it in A. So we've stored that in A. Now we need to go back up here and we need to find side A. Now the nice thing is that's the only piece we don't know. I'm going to have to use sine alpha over A because I don't know A. Now you can use sine gamma over C because you have stored gamma, correct? I'm just going to use I'm going to use beta and B because I haven't stored anything. They're just nice numbers sitting there. So that's going to give me sine of alpha, which I've got stored, right? Right? I'm going to just box that to remind myself that that's stored, over A equals sine 130 over B. Now remember, side A is the piece I'm looking for. I know alpha, it's just stored. How do I solve it? Can you do this all in your head and get A equals? Can you do that that's 15 sine alpha over sine 130? If you can do that all in one chunk, that's fine. Now, let's go get it. I got 5.339. Ladies and gentlemen, law of sines. Law of sines. Super easy. Easy to work with. Now, let's talk. Can I use law of sines for any oblique triangle? Let's go back to geometry. Well, yeah, pretend it's not equilateral. Let's say I know all three sides. So that's a side, side, side triangle, right? Right? Side, side, side. Now, can I use law of sines on a side, side, side triangle? Do I have any one of those three fractions right here where I know the angle and the side? I can't use law of sines on a side, side, side triangle. Can I use law of sines if I know side and an angle and a side? Do I know an angle and its side? An angle and its side, an angle and its side. That's right. That's exactly right. So, can I use law of sines to solve a side angle side triangle? What about if I have an angle side? Yes, because I know a side and its angle. What about angle side angle? Why? Oh, yes, I do. Because if I know two angles, can't I automatically find that one? Yeah. So I can use law of sines here, and I can use law of sines here. So when can I use law of sines? If I know an angle and its opposite side. Now, there is a place for us to write that. Top of the next page. In order to apply the law of sines, what combination of information within a triangle do you have to know? You have to know an angle and its opposite side. And then you have to know one other part. Either you have to know one other angle or one other side. What combinations of information in a triangle would not allow you to use law of sines? Well, we said a side, side, side won't allow us to use law of sines. And didn't we say side, angle, side? Okay. So if the law of sines cannot be applied, then we use what's called the law of cosines. I am very happy to derive the law of cosines for you sometime, but today I just want to show you what it is and let you use it. It's easy. It's easy. Now you're going to be writing 3 lines in that box. Now, last period we had, what do you mean 3 lines? You mean 3 lines this way? I said, no, those are columns. 3 rows. Oh, all right. So there's actually a pattern to law of cosines. When we did the area formulas, remember we had 3 of them? We had 1/2 AB sine C, 1/2 BC sine A, and 1/2 AC sine B. Well, we got 3 of these. Here they go. A squared equals B squared plus C squared minus 2BC cosine alpha. Hey, we could make a rap out of that. Well, I can't, but so B squared plus C squared, you can film it, there you go, minus 2BC cosine alpha. B squared equals A squared plus C squared minus 2AC cosine beta. And C squared equals A squared plus B squared minus 2AB cosine gamma. Ladies and gentlemen, those are the laws of cosines. Now let's look at those 3 formulas. Now look, they really are pretty easy to memorize. If the angle is alpha, the side out here is A. If the angle is beta, the side out here is B. There you go. If the angle is gamma, the sine... What happened? Now, would you please look at this last one? If I covered up the 2AB cosine gamma part, what do you see? What do you see? The Pythagorean theorem, ladies and gentlemen, is a special application of the law of cosines. Oh my goodness. You're not ready to learn it yet, but there is a time in a right triangle where this cosine of gamma is 0, which would make this whole piece right here equal to 0, which gives you the Pythagorean theorem. Okay? I know, it's very cool. You will learn that as soon as you are ready, which will be soon. All right. Now, we are going to solve these 2 triangles using the law of cosines. Now, we're going to do all of this first one and part of the second one. All right, here we go. Look at the first one. What are we given? So we are given a side, side, side. So I can't, for those of you who are listening, Chance Hilburn is getting ready to have a problem. What? You don't have a water? I can find something. I can find something. You, huh? No, you don't know. You don't know any of the angles, do you? But I do know that A is 6 and B is 4. I covered it up, but I think it was a 4. And C is 9. So what I have to find is the 3 angles that I'm missing. So you say, well, okay, I'll go up to those laws, and I have to decide which one to use. I can use any of them because I'm just looking for an angle. I'm looking for all 3 of them. I know all 3 sides. Let's just pick the first one in red. So I want you, at this point, I want you to write down the formula. A squared equals B squared plus C squared minus 2BC cosine alpha. You are going to forget that 2. Be real careful that you don't forget the 2. Now, plug in what we know. We know that A is 6, so A squared is 36. B is 4, so B squared is 16. C is 9, so 9 squared is 81. Minus 2 times B times C times the cosine of alpha. Not hard, though. All right. So what do we got here? We got 36 equals, what's that, 97 minus 72 cosine alpha. That's what we're getting ready to talk about. Notice right here, that is 2 times B times C times cosine alpha. Now, I don't want you to write down what I'm getting ready to write down because I'm going to make a mistake. I'm going to make a mistake that some of you are going to make if I don't try to stop you from it, if I don't try to save you from yourselves, okay? Somebody is going to do this. Why is that a mistake? They are not like terms. Yeah, those are not like terms. I cannot do that. All right. What we're going to do is we're going to subtract 97 and then divide by negative 72. 36 minus 97, what's that give you? Negative 61, I think. And then we're going to divide by negative 72. You can do all that in one step if you want. That's fine. I know a negative divided by a negative is a positive. How do I find alpha? Inverse what? Cosine inverse. Cosine inverse of both sides. Cosine inverse of 61 over 72. You getting about that? Do you have to put the degree symbol? Yes, because you are finding an angle in degree measure. Store that in A. Stow, the redneck word for store is stow. Stow in A. Now, you know angle alpha. You cannot go back and do law of sines. You don't know enough yet for me to explain it. I just need you to trust me that if you start with law of cosines and then you go back to law of sines, most of the time it works, but not always. Sometimes it will give you the wrong angle. Once you start with law of cosines, you stay with law of cosines. But you only have to do law of cosines twice because, yeah, I know that angle. Now let's go after beta, and then I can do 180 minus and find gamma, right? So let's go after beta. Which of those three formulas am I going to use if I want to find beta? The middle one. Write that down. B squared equals A squared plus C squared. Yeah, I know. Write small. Minus 2AC cosine beta. B squared is 16. A squared is 36. C squared is 81. Minus 2 times A times C cosine beta. Somebody's popping bubble gum. Are you getting this? You getting this? How do I get beta? Inverse what? Cosine inverse. So beta is approximately, I'm going to trust you, 20 point what? Does anybody agree with Landon? I hope so too. Do you know how to use your answer key on this thing? Do you know how to use the answer key? Let me just show you how to use the answer key. If I'm going to use this immediately, I don't have to store it. I'm trying to find angle gamma now, right? Which is 180 degrees minus angle alpha minus angle beta, yes? You've got this stored, correct? So do 180 minus your A, which is where you've got alpha, yes? And then do minus answer. Answer is second negative. Multiplied right here. I got 115. Yeah? $180 minus hang on a minute. It may not have liked me using answer. Well, store it. Store it. Yeah, I did it. I did too when I stored it and did it. Huh. Why did it not like? I did 1 minus A minus answer. 180. What did I say? You got the 127? Fine. Okay, I must have just typed something in wrong. Okay, but you're supposed to get. Because it wouldn't be that off. If you do this plus this, what do you get with the real answers, not just the rounded? You get 52, almost 53, right? So 180 minus 53 is 127. Maybe you better store it. All right, we got one more. We are not going to do this whole problem. We are just going to do part of it because this is not a side, side, side. This is something different. So I just want to make sure you're okay in getting it started. You all right? Okay. Please notice, what angle are you given? Well, true. It's acute. It's angle B. All right. So let's get angle alpha, beta, gamma, A, B, C. This is not a side, side, side. This is a what? Side, angle, side. No, it's not angle, side, side. It's side, angle, side. There's no way I can find an angle in its opposite side. So I'm going to have to use law of cosines. Now, there's one of them that I'm going to have to use. I'm going to have to use the one with B in it, with beta in it. So here we go. B squared equals A squared plus C squared minus 2AC cosine beta. Plug and chug. B squared equals A squared plus C squared minus 2 times A times C times cosine of 65 degrees. Folks, you can run that. You can just put it all in your calculator just like that. Yeah, really? Now here's the deal. Here's what somebody in one of the other classes did. Somebody in one of the other classes did this and then took that answer and multiplied it by cosine 65 degrees. Why did they get it wrong? That's right. The cosine of 65 is only being multiplied by this piece. Now that's B squared, right? What's B? Now you do square root of answer. 11.045. Store that in B. Yeah, you got to take the square root of the answer because you're getting B squared. Now I know B. So what would I do now? I need to find alpha and I need to find gamma. I'm going to find alpha or gamma the same way we did on that first problem, right? Once I find it, then all I have to find is one other angle. Do 180 minus. Yep. Yep. That's right. Law of sines and law of cosines are big deals. We'll use them a lot. So you're going to get some practice with them. Here's what you need to remember. You can use trig ratios only on right triangles. You can use law of sines and law of cosines on any triangle. However, I want you right now just to use law of sines and law of cosines on triangles that are oblique. If they're right triangles, I want you to use your trig ratios.